Actually, I lied. Today in section 2.1, we're only looking at finding the angles. Tomorrow in 2.2, we look at finding angles, or finding sides. So example 3 says here a wheelchair ramp is 4 meters long. It rises 0.7 meters. What's the angle of inclination to the nearest degree? Well, an angle of inclination is an angle that measured from the horizontal is an angle that goes up. Angles that go down from a horizontal, these are called angles of depression. I don't think I can fit that in a P or S-S-I-O-N. Angles of depression. Okay, so we're looking for some kind of angle of inclination, an angle that goes up from a horizontal. Now, with any of these trig questions that don't have some kind of picture of a triangle, the first thing you really should do is draw a picture, because it's so much easier to look at if I have some kind of idea of what I'm looking at. So there's our horizontal ground. So this is our ground. We have a ramp that goes up. And it is 4.2 meters long. 4.2 meters long. And it rises a height of 0.7 meters. So there is our triangle, and we can assume that this here is a 90-degree angle. What is the angle of inclination? What is the angle that is made as this ramp goes up, this angle? So there's our triangle. First step after having a triangle is to determine, well, what do we have? Let's label our triangle. Well, this side is the hypotenuse. This side is the opposite, and this side is the adjacent. Okay? And at this point, the only thing we know about is tangent. The only thing we know is tangent of some angle is equal to opposite over adjacent. But we don't know our adjacent side over here. We don't know this side. But knowing that we have a right angle triangle, and we have two sides of a triangle, right angle triangle, we should be able to find this third missing side by using Pythagoras. Okay? So I start with my Pythagorean theorem. C squared is equal to A squared plus B squared. Remember, C is always the hypotenuse. It's opposite to the longest side, or opposite to the 90-degree angle. So this is going to be 4.2 squared is equal to A squared. Let's call that 0.7 plus B squared. And remember, if I'm looking for B squared, I'm going to have to subtract. So this is going to be B squared is equal to 4.2 squared minus 0.7 squared. That's kind of ugly, isn't it? There. Start punching that into your handy dandy calculator. Well, 4.2 squared minus 0.7 squared. I don't have the intermediate steps done, but I have this being 17.15, which then I need to take the square root of this and the square root of this in order to get B to be the square root of 17.15, which is equal to 4.1412558. So now this is our adjacent side. 4.1412558. Okay, that's our one side. Now I have the two sides that I need in order to do my trig ratio, opposite over adjacent. So I can go over here again and I can fill in this formula. Well, we're looking for some angle. Let's call this angle X. We're looking for this angle, angle X is equal to my opposite side, which was 0.7, over my adjacent side, which I calculated to be 1412558. Yes, decimals are necessary. Tangent of x is equal to 0.7 divided by that gives me 0.1690308551. And now I'm thinking, well, if tangent of x is equal to that, then angle x is equal to the inverse tangent of that. Okay. Another way to remember it is, if I have this here still, because I'm using my formula like a good boy, like I always do, and I've got some ugly, funky decimal number, I think to myself, well, I know I'm looking for an angle. I should have some ugly, funky decimal number, so I have to use the inverse function. So angle x is equal to the inverse function of tangent of 0.169030851. Into your handy dandy calculator, you get out 9.5940. I think that's a 6 I have written down, or rounded to nearest whole number, 10 degrees. So my angle of inclination for this ramp is 10 degrees.